So we're just gonna finish up example 4, 5, and 5. And then the very last part here, completing the table, it's just like an extra stuff that you could work on to practice on and for you, okay? So example number 4, it says here, determine algebraically, okay, the inverse of this quadratic function. So determine algebraically. That's not bad. We swap the x and the y. So it becomes x equals to negative y squared plus 6. Okay. And then we're going to isolate the y, have the y by itself. So let's go ahead. Why don't you go ahead and try that? I'll do it on my page. And then just keep looking, see if you're in the right track. So the very first thing that I did is I put the positive 6 to the other side of the equation, so that's a minus 6. Now what am I going to do first?
Minus both sides.
Yeah, so yeah, you could also multiply by a negative 1 on both sides, or another way, dividing. Oh yeah, okay, so that's another possibility too. So yeah, we have quite a different possibilities here. One person was saying that we can multiply by negative 1 on both sides. Yeah, that's okay. Another possibility is to switch them around. So this negative y squared will go to the other side. That will make it a positive y squared. And then this, everything in here goes on the other side. So that becomes negative x positive 6. Oh, I like that idea. Okay, very good.
If I just, if I say, I can square negative. If I just say, if somebody don't think to just to get off the minus, that comes in the right hand of y square. So we say, this one, we can't square negative. And say,
Yeah, then that's not necessarily true. So what we could do is you could just divide it by negative 1 or transfer it. Yeah, okay. Okay. And then now, when you look at this one in here, get rid of the squaring, so square root. So y is equals to the square root of negative x plus 6, but then again, plus or minus, right? So we have two possible functions. We have either y equals to the root of negative x plus 6, and then the other one would be y equals to the reflection in the x-axis, so negative x plus 6. Okay. If you want to do some transformation stuff, okay, because I know what we wanted to do is to graph this thing. To put it in the transformation form, we have to factor out the negative 1, because the x has to be a positive x. So factor out the negative 1, so it becomes x minus 6. So that tells us that there's going to be a reflection into the y-axis, and then translation 6 units to the right. Okay. Now this part in here, y is equals to negative square root of negative x minus 6. So this is a reflection in the x-axis because of a negative a value. So what we're going to do is, if we want, we can just graph this thing, right? How do we graph that? We know it's a quadratic function. It's going to be 6, 0. So that's the vertex, or 0, 6 rather. And then because the leading coefficient is negative, so that means it's pointing down, right? So what would that look like? So 1, 1, 2, 4, and then 2, 4. So the graph looks like this part. Oh, it's no good. Okay. So I'm actually relying on what you remembered from grade 11 pre-calculus. So this is a quadratic function. Okay, so if we were to graph the inverse, what we can do is we can just take some of the points in here and then reverse them, right? Or inverse them. So this is good.
We're going to do the other way, how it comes out as well.
Yeah, we could talk about that in a second. Yeah. So let's do this one first, because this is the easier version of that. Okay? So in the f of x, the points would be -2, +2, -1, +5, 0, 6, 1, 5, and then 2, 2, 2. Now to do the inverse function, I'll do it in this. Okay, so it's going to be flipped, right? So it becomes 2, -2, 5, -1, 6, 0, 5, 1, and it's still going to be 2, 2. Now let's graph this thing. So 2, -2, 2, -2, 5, 1, 5, -1 rather, 6, 0, 5, 1, and then 2, 2. So it goes like this. Two, 2. And that one certainly looks like a reflection in the y equals to x line. So I'll draw the y equals to x line. Yeah, so that one looks like it's a reflection in that line. Okay. The question that Khalid was asking was, yeah, this is one way to figure out the graph of the inverse function, but asking about what if we do it from graphing from this part, right? Okay, so that's a good challenge. So here's what we're gonna do. We're gonna graph it from this one. So we know that the graph is y equals to negative square root of negative x plus 6. Before we do the transformation, we have to factor out a -1. Is everybody okay with that one? You factor out the -1, and that makes it x minus 6. Yeah? Okay. Would you like me to explain that? Why? Okay. In the general form, y minus k equals to a times f of b x minus h. Okay. This part here is positive x. Positive. So we would have to factor out a value so that the x is by itself. So here it's negative x. So we have to factor out a negative x so that the x is a positive. Okay? So that tells us, what kind of transformation is that? This negative, so b is equals to a -1, and that's a reflection into the y-axis, right? So if it's the x is on this side, it becomes on the opposite side of the y-axis. And what's this one? That's the h. H is positive 6, so that means a translation 6 right units. Okay? So, let's see. Here it goes. What's the parent function? What's a parent function? The parent function y is equals to the square root of x. Okay, so I think by now we know what the square root of x looks like, right? I'm going to do it as a in a pencil. So square root of x is 0, 0, 1, 1, 4, 2. So this is the square root of x, what that looks like. Now this one here, there's a reflection into the y-axis and translating it 6 units to the right. So reflecting it to the other side and then translating it 6 to the right. So if it's 0 here, and if we reflect it onto the y-axis, it would still be 0, right? So, and then it's going to be 6 units to the right. So it's going to be 6 units to the right. 1, 2, 3, 4, 5, 6. So it's going to be going this way. This one here, it's going to be reflected onto the y-axis and then shifting it 6 units to the right. So 1, 2, 3, 4, 5, 6. So that's this one. Okay. What about this one? This is a over here, positive 4, reflecting it onto the, okay, it's going to be negative 4, and then shifting it to the right, 6. 1, 2, 3, 4, 5, 6. So the graph looks like this part. Okay. Did we get the same values? Did we get the same values? Okay, I'm going to erase this because this is not the inverse. So that's the 6 zeros right there. And then 5, 1, that's that one right there. And then, where's the other one? 1, 2, 3, 4, 1, 2. It's going to be 2, 2. 2, 2. Okay, so that's that piece. Now, what about the other one? Because that's the one part of the inverse. The other part of the inverse is y equals to negative square root of negative x minus 6. So everything is the same in here, right? But then there is a negative in the front, so that means the a value is the front. Its reflection onto the x. So it would look like this part. Okay, so it kind of looks like that one now. Looks like that one. So, yeah. Certainly we got two options. We can certainly graph it using like this. And then the inverse, we pick the good points and then swap them, right? Change the position of x and y's. Or we can pick it up from the algebra, and then we're gonna end up with the same thing. And it's up to you. You could choose either one. Who likes this one better? Oh yeah, the 2 hands up. Who likes this one better?
This one is good.
This is actually,
It's good to know
Yeah, it's also good to know. It's also, yeah, certainly it's good to know. But if I were to do this, if I'm a student, I'm gonna do the easy way. Right?
Save time as well.
Save time, yeah, yeah, exactly. Exactly. Okay, we're in the last bit of this marathon. Now, example number 5, it says here, determine algebraically if this and this are inverse of each other. So we gotta see if these are inverse of each other. We can't just say yes they are or no, because we have to somehow show some justification, some work. Okay? So let's go ahead to see if this are inverses of each other. So I'll start with this one. It's going to be x equals to 7y minus 3. Okay. And then what we're going to do is we're going to work algebraically so that we can isolate the y by itself, right? Isolate the y on one side. We're solving for y, so bring this over there. So it's x plus 3 equals to 7y. And then to get rid of the 7, so divide by 7. So it's going to be x plus 3 over 7. So x plus 3 over 7. So that means, yeah, they're inverse. So yes, y equals to 7x plus 3, or minus 3, is, and y equals to x plus 3 over 7 are inverses of each other. Actually, this is not going to be the only inverse thing that we're going to talk about. Okay? We're going to talk about the inverse of exponential function and logarithm function. So, yeah, it's a nice prelude to that when we get to the... Okay? Let's take a look at the letter B. This is the last one. Determine algebraically whether the functions are inverses of each other. So let's work this out and then see if it matches that one. Okay, so swap the x and the y. And then isolate the y. Okay, what are we going to do next here? Yeah, we can multiply each side by -1. We can also divide by -1, or we can bring this to the other side and bring this side to the other side. Have the y by itself. Right. So let's do that. And then from there, we can take the square root. Take the square root. Negative x plus 3. But then this one here, they have the 3 first and then the x. So y equals to 3 minus x. So, yes. The only thing that's not, so it looks like they're inverses of each other. Determine algebraically whether the functions are inverses of each other. So this one here, it looks like it matches, right? But this one is supposed to be plus or minus the square root of that. Okay, so in this way, so y equals to the square root of 3 minus x is just a part of the whole inverse?
Look, with the limitation of x cannot be greater, must be greater than or equal.
Oh, yes, yes. Oh, okay, sorry.
Inverse it would be y. It's greater than.
Okay, yeah, actually, thanks for pointing that out, because I didn't even pay attention to this. So x is greater than 0. So x is greater than 0. So if x is greater than 0, then it's going to be I'm going to graph this for a second. 1, 2, 3, and a negative x squared. Right? That's for the whole thing. But then they said x is greater than 0, so that means I'm going to cut this off. So this is the only part of the function. And then this part is 3 minus x. That's going to be I totally disregarded that piece. Square root of negative x plus 3. So this is a reflection into the y-axis. So it's going to go like this. So yeah, they are. Yes. So yes. How can I fix this? So y3 is the inverse. Erase this part here. The inverse of y equals to negative x squared plus 3 when we're just focusing x as greater than or equal to 0. Okay. So this is that part there. So yeah, they are inverses of each other because of there's a restriction on the domain. Okay, that's great. Thanks for pointing that out. And who's gonna question me next time when no one's here? That's okay. So that
They're inverse of each other, right?
yeah, they are inverses of each other. Yeah, only when x is greater than or equal to 0. Okay, so that's that. That we've completed everything.